The final step in every storm sewer design is the actual hydraulic analysis leading to precise pipe sizing. So what we'll do is we will drop into Precision 3D hydrology through Dynamic CAD, and we will accept this as the correct tin, and this launches P3D. Now here we always double click the tin in the Scene Explorer, and I like to change my material to ground, and I'm going to go down to this material, just drag and drop, and that has, if I double click it, a 0.35 runoff coefficient. This is going to be critical now in hydraulic analysis because we're going to first design a storm sewer system consisting of a run of pipe. So we'll go from this low point in the curb, we'll switch over to a downhill facing manhole lid in a 10-foot curb inlet. We'll use the 10-foot curb inlet here at that low point, here at that low point, and then we'll finish up with a head wall along this right there. All these slopes are correct. It's using a -0.1 minimum. It had to go steeper on pipe 2 because of the relative elevation and minimum manhole depth, which was active. So going down 3 feet or whatever the minimum was at that location of manhole number 3 forced a slightly steeper slope than the allowable minimum or the set minimum. Now what we'll do is click on the pipe network. We'll expand it first, and if we select any pipe, you can see all the information about the pipe. That's the last run of pipe. I can even change it to PVC, and we can take a quick look at it, and you can see that one there is PVC, and the main run of pipe is concrete. And then what we'll do now is by clicking on pipe network, we're going to analyze it and then go on and edit the sewer network. So we're going to hit analyze. And on this relatively small DTM, it only takes a few seconds. We did not put inlets in on the tributary side road, so we only have the main run of pipe. Now, the next step is to skip over to icons and go to Edit Sewer Network. And you can see that we have very high hydraulic and energy grade lines. So if we change the last run of pipe to 18 inches, the PVC pipe, you see we're holding the crowns based on this setting here, so it pushed down that last pipe, and now the hydraulic grade line is barely acceptable on the last run of pipe and still unacceptable elsewhere. What if we change this one also to 18, and then this one here to 18, and continue on to the first run of pipe? Might as well use 18-inch pipe everywhere. We may need to go to 24 inches on the first pipe. And that pulled everybody down, so none of the manholes are experiencing any pressure in the pipe. And we have it done. And notice that the pipes are larger now. If we come in here, you can see the beautiful 24-inch PVC fed by an 18-inch concrete pipe. And however, the pipe got so big, it actually crossed over the corner of our catch basin. So if I click on the pipe and grip its connection point, then all the acceptable connection points for that catch basin are presented, and I can move it to this new position and we're good to go. So if we go back to the CAD and look at model space, you can see everything has moved positionally as well as being correctly labeled. So that is the essence of hydraulic analysis using P3D Hydro. We've completed a storm sewer design very quickly.